Hello everyone, so today we will be looking at this problem, check if grid can be cut into sections. So the code is 3394 and it is a daily Leetcode problem. So let's look into it. So we are given an integer n, okay, this is n equal to 5. Over here you can see this is a 5 by 5 grid, okay, and we are given the opposite vertices coordinates of a rectangle, okay, 1 comma 0, this is 1 comma 0, 5 comma 2, this is 5 comma 2, and these are opposite vertices, okay, diagonally opposite vertices of a rectangle. Similarly 0 comma 2, 0 comma 2, 2 comma 4, this one. So this red one is corresponding to this. 3 comma 2, this one. 5 comma 3 is this one. So this is diagonally opposite and this forms a rectangle. Similarly 0 comma 4, 0 comma 4 and 4 comma 5, 4 comma 5. This is diagonally opposite and it forms a rectangle. So these are the points we are given. What we have to draw is we have to draw two horizontal lines or two vertical lines in such a way, okay, either of these two, okay, either two horizontal lines or two vertical lines, such that after drawing those two lines, right, in this diagram we have drawn two horizontal lines. After drawing these diagrams, two conditions would be satisfied. The first condition is the rectangles which are there, okay, it should be present in every section. This section 1, section 2, section 3, okay, with two horizontal lines, three sections will be there, right? So in every section at least one rectangle should be there. And the second condition is this rectangle should not be part of two sections. It should be completely part of one section. That is, cut should not cut the rectangle in between. Okay, so any rectangle will be completely part of that section. That is clear, right? If you can find those two horizontal lines or two vertical lines, then you have to return true. If you are not able to find that, you have to return false. Let's look into this example. This is a very simple example. It's just they have converted it into 2D. It's a famous example of merge intervals. Okay, so if you will see over here, right, so here we are applying a horizontal cut, okay, and here if you will see, we just need to focus on the y coordinates of the rectangle, okay. There is no need to focus on the x coordinate for as of now when we are checking whether the horizontal cut can be made or not, okay. So if we just try to plot the y-axis, if we try to plot the y-axis, for example, in this 1 comma 0 comma 5 comma 2, 0 is the start and 2 is the end. 0 is the start, 2 is the end. So we draw one line over here. Similarly, if you see 2 is the start, 4 is the end. 2 is the start, 4 is the end. We draw this line. Okay. 2 is the start, 3 is the end. 2 is the start, 3 is the end. We draw this line. 4 is the start, 5 is the end. 4 is the start, 5 is the end. Why we are taking this 4 and 5? Because these are start y and end y. Okay, we are just taking the y parts. Okay, so now if you will see, observe carefully, right? So this is like one edge of the rectangle. Okay, this is kind of one edge of the rectangle, one edge of the rectangle, one edge of the rectangle. Now we have to find those lines, or like if you will see, these are the lines, right, at 2 and at 4, okay. So we have to find these two lines, so such that these rectangles in between, right, completely comes in between and they don't intersect. So if I draw line over here, right, so as you can see, it is not intersecting anything, okay. If I draw line over here, it is not intersecting any of these lines, okay. So we are able to find these two horizontal lines, so our program will return true. So how will we figure it out that it will not intersect? So the condition is very simple. At this point, okay, you stand at this 2 point. Observe what is happening over here. There can be lot of options for you to put the check. So one option you can say is whatever is the end over here, right, and whatever is the start. So end should be less than equal to start. So if the end over here, okay, is less than equal to the start, okay, end of all the previous lines, okay, which means the maximum we have to take the end, the maximum end we have to take, it should be less than equal to the immediate start. If it is less than equal to immediate start, that means there are no more lines, okay. The maximum end from here, okay, which is this one, should be less than equal to this start. That means there is no line, so that means we will increment our counter, okay. That increment our counter means we will maintain a line counter which is initialized to initially 0. We will increment it, that is we can have one line over here, okay. Then coming on to this fourth coordinate over here, you see again at this point what is the max end. Max end of the line is this, okay, because this end is again less than this end, this end is less than this end, so this is the maximum end. And what is the next immediate start? This is the next immediate start, okay. So this start is greater than equal to this end, okay. So that means we have to increment our counter again, the line count. So the line count will be 2. So as we can make 2 line, okay, line count equal to 2 means we can draw 2 lines. So that means we will return true. If we are able to make less than 2 lines, just 1 line, okay, then that means we will return false, okay. 1 line means we will not be able to divide it into 3 sections, right? So that's how it works. So we will take another example. This we took example of the horizontal line. We will take example of the vertical line as well. So as you can see in this diagram also, right? What we will do? Simple. We will simply plot the x coordinates. So 0, 1, 0, 1 we plot. Okay. So 2, 3, 2, 3 we plotted. Okay. 0, 2, 0, 2 we plotted over here, and 3, 4 we plotted over here. So now if you will observe here, right? Okay. So this 2, okay, over here you will see, and over at this 3, okay, you will see. These 2 are the main points where we can draw the vertical line. So how did we detect that? There can be many ways of detecting. First we will have to do is we have to sort this, okay. We will sort this based on the x-axis or y-axis, based on what we are finding, whether we are finding the horizontal line or the vertical line, okay. If we are trying to find this vertical line, we will sort it by the x-axis, okay, otherwise the reverse in the previous example, okay. So once the sorting has happened, then the thing is very simple. We have to find these points, okay, these intersection points. So in order to find these intersection points, one way is we can create a map like we did in count days without meetings, okay. That was taking order of n space, okay. So probably we can optimize it also. We could have optimized that problem also. You can see the YouTube playlist. There you will find this question, count days without meetings, how we did that. We will get the answer, but let's try to do it in the order of one space. So what will be the condition over here? The condition we will maintain the maximum current end, okay. What is the maximum current end which is there? So the maximum current end is this, till this point, okay, and it should be less than equal to the next this line, okay, whatever line is coming, it is less than equal to this line, right? So here we will increment the counter. But if you will see over here, what is the maximum end? Maximum end is this one, okay. So it is like the next over here it will not be satisfied because maximum end is breaching. So as soon as the maximum end is less than equal to this start, okay, so at that point we will say that okay, the condition gets satisfied. So over here also the maximum end will be this, okay, and the next start will be this. It is less than equal to this, so that means we will increment the counter. Since we have incremented the counter 2 times, that means we can draw 2 vertical lines, at least 2 vertical lines, right? So if we can draw at least 2 vertical lines, then that means we can divide it into 3 sections. So that is the simple thing. So if we look at the code, right, so we will just check for horizontal cut or vertical cut, whether we can draw horizontally or vertically. If we can do either of these two, right, then our work is done. We have to return true. That's what we are doing. Can partition horizontally or vertically. Now how it looks like this function, if you will see, we are taking the start index and the end index and the corresponding axis, okay. So what we are saying is where the section is starting, okay. If you will see over here, so this is the section start, this is section end, section start, section end, okay. So this is how it is happening. So we are just checking that where the section is starting, we are initializing it to the start index of the first point, section end is the end index of the same point, the end index of it, okay. So if you will see over here, for the same rectangle, we have initialized it to the start index and the end index, okay, where it is ending. So if you will see over here, so section start, section end. In this example, section start is this, section end is this, okay. So once we have initialized, so we will have a for loop over here which will check that whether it is this condition which we talked about, right, that whether if the start index is greater than equal to section end, then we are incrementing it, Otherwise what we have to do is, otherwise if you will see, we will have to merge it. Okay, like in this case these two lines were overlapping, right? So what we will do is, we will like merge 2 to 4. So over this section will become the bigger section, like the start will become 2, the end will become 4. Okay, that's what we are doing. So here we are extending the section. How we will extend? Start will remain the same, but the end section will be extended. How it will be extended? It will be the max of rect of end index and section end. Okay, in the overlapping section. But in the new section, we will be incrementing this line count, because we are getting a new section. That means one line can be drawn. That's why we are incrementing this line count, and we are, after incrementing it, we are updating our new section. Okay, so in this case, after we have encountered this line, right, after we have encountered this path, okay, so here we will increment our new section to this start, and end will be updated to if this line comes this, and if this line comes this. Okay, when the next line this will come, we will extend it. Okay, so you can see over here, start a new section, line count is incremented, start section equal to rect of start index, and end index section of end equal to rect of end index. So now we will keep on doing this, and at the end we will simply check if the line count is greater than equal to 2. We can check in between also, so that it breaks early, that as soon as the line count is equal to 2, right, we just have to return it. Okay, so we added condition over here, okay, as like return line count greater than equal to 2. So this is the complete code. Like can partition is calling this, and based on the like axis we are passing 0 or 1 based on like whether we are checking horizontally or vertically, and start index we are passing 0, 2 or 1 or 3. Okay, why we are passing 0, 2 and 1 or 3? Because start x and end index is present on 0 and 2, start y and end y is present on 1 and 3. That's why we have to pass 0 and 2, 1 and 3. This is kind of this has 4 elements, right? That's why we have to do like this. I hope this is clear, right? So this, if you can see, that space complexity is order of 1, whereas the previous question which we did, right, the count days without meeting question which we did, over there we solved it in order n space. The same approach we can apply over there, and we can solve it in order 1 space. So this you can take as a homework, right? And if you will see, what's the time complexity? Since we are doing sorting, right? So sorting is the major one. This will take order of n. This is simple for loop. Okay, and there will be n rectangles, but this sorting will take n log n. Okay, and the space complexity, since we are not taking any extra space, we are not considering this rectangle space. So for that, the space complexity is order of 1. Yep. Thank you so much.